Okay, we are on 5-6. We are getting done with this section today, I hope. Homework is out of the book. There it is. Luke, go away. We, I think, are on the...
Oh, that's a lot of homework.
We just got done with example 4. So we've got 5, 6, and a little bit left on the backside. So here we go. Number 5. Here we go.
Wait,
Oh, you know how to do this.
What?
Okay, example 5. The top one is going from 1 to 1 of x squared. So, like, if we just think about, like, x squared is a parabola that starts and goes like this, right? And we're doing the slice from 1 to 1. 1 is here and 1 is there. So I'm trying to figure out the area of that little slice right there.
0.
But he's going to be 0 because he has no width, right? Okay, so first one is 0. Now the second one is going from 4 to 0 instead of from 0 to 4. Normally you would see like from 0 to 4 and you would go like this, right? Of x dx. Okay, so, all right, let's do this. What's the antiderivative of x?
Wait. Why is it 0 over 4?
What?
Why is it 0?
Because you're going from 4 to 0. So like you're reading, it's like you're reading the area from right to left instead of left to right.
Does it really
Weird
change
stuff.
anything?
It just makes it negative of what it would have been. What's the antiderivative of x?
X, or no, half x.
1/2 x squared. Okay, then we're going 0 to 4. So if it's from 4 to 0, we're plugging 0 in first. You plug the top number in first. So 1/2 times 0 squared, that guy, minus 1/2 times 4 squared. So this is 0, you're right. 4 squared is 16, half of 16 is 8. So normally, if we were going 0 to 4, it would have been a positive 8, but now it's a negative 8 because it's like you're doing the area backwards. Okay, so negative 8 is what they say. Okay? Good, no. I mean, the graph is this guy. He is x, which is like y equals x, and x is a linear function. And you're going from 0 to 4. So this area right here.
Oh, it's a straight line. I thought they were all...
Oh. Yes, no, that's right. X,
This is a straight line?
y equals x, going from 0 to 4. Is that truly 8? Yeah. Yeah, because 4 by 4 would be 16, and half of 16 would be 8. Yeah, right. So that's what that area would look like. Okay, example 6. They're wanting us to go from 0 to 3 of f of x dx, but f of x is actually a piecewise function. What the heck?
I don't like piecewise.
This is not bad, actually. What? Yeah, we're going to split it up into 2 chunks. So we're going to go from 0 to what? 0 to 2, and that function is which one? X squared. Okay, plus, then we're going to go from 2 to 3, and that function is 3x minus 2, that guy. dx, I should put dx on the end of each one of these, dx. Okay, so do you see why it's 0 to 2 and 2 to 3? 2 is my cutoff mark, so I'm going to do this bottom function until I get to 2, from 0 to 2, and then the top function until I get to 2, and then the bottom function until from 2 to 3. Okay, and then we just do it like normal. So, antiderivative of x squared, 1/3 x cubed. From 0 to 2, should we go ahead and solve that guy all the way out before we do the other?
Yeah.
Okay, I'm plugging 2 in first. So 1/3 of times 2 cubed.
It's 8 divided by 3 is what?
And then we plug 0 in, and you know 0 is going to end up being 0.
So 2.7.
2.7 is what this one is.
Yeah.
8 divided by 3 is 2.67 probably.
Oh yeah, 6, 7.
We'll go 6, 7. We'll go 2 decimal places. Okay, then I'm going to add to that whatever this one is. So we're going to do the antiderivative of 3x minus 2. What's the antiderivative of 3x?
3 over 2.
You got it. 3 over 2 x squared, right? Minus 2x. And now I'm going to plug in 3 and 2. Plug in 3 first. So 3 over 2 times 3 squared minus 2 times 3. And then minus what I get when I plug 2 in. 3 over 2 times 2 squared. Minus 2 times 2. And I get a bunch of stuff.
Minus.
Hold on, I get a 9. This is 27 over 2, which is 13.5 minus 6, which is 7.5. Is that what you said? 7.5? Minus, this is 2. 4. This would be 6 minus 4 is 2, so 7.5 minus 2, which is 5.5. So 5.5 is that area, and if I add those together, that is like 8.17.
Hang on, we gotta use the full number though.
8.1. 8.17 is 8 1/6. Because 1/7 would be like 0.16 repeating, right? This is 8.16 repeating, and that's 1/6. So 8 1/6 or 8.17, whatever.
What are we doing tomorrow?
Okay, tomorrow in here, doing the next section.
Okay. I'll be gone. I have a doctor's appointment.
Okay. Okay. Right. That was example 6. Example 7, they have a graph for you. Oh. So they don't give it to you in interval form, they just say, here's the stuff. So find the total area between the curve of 1 minus x squared. Why the heck do they have this line right here? This is confusing. Your function is only doing this right here. But the reason why they draw that line there is so that you can see like the starting and stopping. So this is not actually a part of the function. That's like the boundary.
Yeah.
You see that? Okay, your function's not doing one of these, right? Okay, that's the boundary. So we're going from 0 to 2. And so what we have going on here is 0 to 2 of 1 minus x squared dx. All right, what do you notice before we do this whole thing?
We have to split them.
No, you don't. That's not necessarily.
Oh, I thought we did since he was going to, like,
Nope.
because he went up
Nope.
and then went down.
Because he's still following the same function the whole time.
Oh.
Yeah. Like the whole function is 1 minus x squared. But when we get an answer, I'm going to guesstimate that that answer will be negative because there's more negative area than there is positive area. That's what I'm going to guesstimate. Okay, so let's do derivative. Antiderivative of 1 is 1x
1x
minus
a third.
1/3 x cubed. Okay, and we're going to plug in 0 and 2.
Well, 0 is 0.
0 will be 0, yep. So 2 minus 1/3 times 2 cubed. Minus, we know that this one will be 0 when we plug it in. This is 8/3. So 2 minus 8/3.
Negative 2/3.
2 minus 8/3. 2 is 6/3. Minus 8/3. Negative 2/3. Yep, I buy that.
Negative 2 over 3. Oh, we have to
So,
subtract the 0,
no.
so that's not really doing anything.
Right, right. So what they're saying is, like, if I cancel this out with some of this, I'm going to guess, like, maybe that amount would cancel. This is still 2/3 of a unit that we have left over that's negative.
It's funny how the
Yep,
students are better.
yep. What happens if we would want to know, like, the total area, like the absolute value of the total area, not just the stuff that, like, would cancel? How would we do that?
What? Say that one again?
If I wanted that total area, if I want to know the area of this and this together, like positive, both. What? Split it up. Yeah, I would look at the area from here to here, add that to the area from here to here, but we would have to change that to a positive area, obviously. Like, yeah, so we could totally do that and find like the total area. It doesn't matter if it's above or below. Makes sense? We would have to split it up if we wanted that. Okay. Yeah, find the total area between the curve of blah, blah, blah. Okay. All right, last thing.
Always reminded me of water.
What?
This random area reminds me of water.
Area reminds you of water? Okay,
Because if you have
interesting.
you have a box, you want to know how much area it holds, you fill it with water, find out how much water is in it.
Yeah,
I don't know.
right. 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 Or like they do that a lot of times with like trying to find the volume of stuff that's not like normal shaped. Like the whole area of the donut thing or the volume of a donut thing. Like we could use calculus to find the volume of a donut thing. We don't know how to do that yet, but I think we'll get to that point maybe. We'll see. But like you could do the water displacement or whatever and figure out what the volume displaced is, which is kind of interesting. I always kind of think that's cool. All right, here we go. This is something called the mean value theorem. The mean value theorem, okay? This is not that hard of a concept, but it's kind of like, okay, that's weird. Here's the deal. Look at this first diagram. We are trying to find the area from A to B underneath of this curve, and they call it f of x, so we don't actually know what the formula for it is, okay? But what we're doing is we're trying to find the mean value, and here's what the mean value is. If I look over here, I want to know Here's what I want to know. I want to know where on this graph I can put an X down so that the height touching the curve, if I were to make a box out of it, the positive and negative areas would end up canceling each other out. Right? So like this area plus this area will be the same as this area. In other words, if I put an X down here, whatever the height of this box times the base, like this box area will have the same area as this curve area, right? Now I can see that like I can't just put it anywhere. Like for instance, let's say I put my X value here, right? Ooh, I didn't mean to do that. If I put my X value there, then this box is only going to be this size, right? And my positive and negative areas are going to cancel each other out, right? Or even if I put my box like, let's say I put my box like here, let's say I put X here. If I make it that big, do you think my positive and negative areas are going to cancel each other out? This is my positive area. This is my negative area. Do you think that will be like, I'm way under, right? Okay, so I would need to like go up a little bit higher, right? So I'll have to move my X over just maybe ever so slightly, like where they had X here, and that would make, something like that. That would make this area and this area cancel out with that one, right? So what I'm trying to do is I'm trying to find the mean value or where this X is located in order for this height and that length to be the area which is the same that's underneath of that curve. It's like trying to find a happy medium, right? Trying to find the mean value, okay? Here's what the mean value is. I'm taking just the regular area underneath of the curve from A to B, and all I'm doing is taking 1 over B minus A. Okay, I'll show you what that does here in a second. Let's actually see a problem, and then you'll get the hang of it, okay? So since f of x equals x squared is continuous on the interval from 1 to 4, the mean value for integrals guarantees that there is a point from 1 to 4 such that I cut off.
It's fine.
Okay, we get it. Let's do this thing. So we're going from 1 to 4 of x squared, all right? I'm just going to graph and see what this thing looks like. All right, x squared is this function like this. He's a parabola, right? And we're going from 1 to 4. So I'm going to make my parabola a little bit wider so that you can see it a little bit better. Like this. Here's my parabola. From 1 to 4. Okay, here's my from 1 to 4. From 1 to 4. All right? I need to figure out how tall I need to make this thing. So I'm going to go like right there-ish. And I'm going to say this has to be where my x needs to be in order for this positive area to be the same as that negative area. Maybe I should have moved it over a little bit. I'm going to move it like here a little ways. So I'm going to put x there. This area cut off replaces that area. I don't know. Do you think?
Sure. Oh, yeah.
Do you think he's more than halfway or less than halfway?
Oh, I'm at 7 graph.
What?
That's my answer.
You think it's where?
No, I said
Oh, you found the exact. Okay. Okay. So here's the deal. If we do the formula, we do 1 over b minus a from what, a to b. They go from a to b. Yep. Of f of x dx. This is the formula that we're using. Okay. All right. So 1 over what's b minus a going to be?
C.
4 minus 1, so 1/3. Okay, integral from 1 to 4 of x squared. All right, so we're going to do this. 1 over 3, that's that outside. Okay, this antiderivative is 1/3 x cubed. And we're going from 1 to 4. Okay. Okay, now let's plug our numbers in. So I've got 1/3 times 1/3, 4 to the 3rd, that chunk, minus 1/3 times 1/3 times 1 to the 3rd power. That's a lot of 1/3s and such. Okay, 4 to the 3rd is 64, and 64 divided by, that'll be divided by 9. 64 divided by 9 is 7 1/9, I think. Like 7.1 repeating. Somebody check that and make sure that that's true.
Minus
Minus
is equal 7.
minus 1/9. So we just get 7. Yeah? 7. Okay, now 7 is going to be, hold on. 7, the area of the shaded rectangle is equal to the area of the shaded region. They are saying that, okay, the whole area underneath of this curve would be 21. Yeah? True?
Why?
Okay, the whole area underneath of this curve, because we took a third of it, right? A third of this number gave me 7, yeah?
Yeah.
So the area underneath of that curve is 21, right? But what this means is average value. Here's another way of thinking of average value, okay? There are 3 units from 1 to 4. 1, 2, 3. 3 units from 1 to 4. Each one of those units is containing 7 units, right? Okay? So this box is 7 units tall. Does that make sense? And 1 unit wide, right? 7 units tall and 1 unit wide. Okay, so here's the deal. Here's the deal. If my box is 7 units tall, this is like the y coordinate, okay? I am trying to figure out if that box is 7 units tall, this is the function y equals x squared, yeah? I want to know where it's going to touch right there. If the y coordinate is 7 units tall, what will the x coordinate be? Like, how far over is that x so that he reaches up 7 units tall, right? So to solve for x, I would take the square root, and technically when you take the square root, it's plus and minus, but we're only, like, minus would be over here, plus would be over here. I'm taking the positive square root of 7. What is the square root of 7? 2.65. So 2.65 is going to be where he is going to touch on the x-axis. That's how far over I need to go. I need to go over 2.65 and up 7 units in order to get my box to be the same size as what the area underneath of that curve would be. Like this point that's going to touch is going to be 2.65, comma, 7. Do you see how that works?
2.65 away from, or like 2.65 up
2.65 over
and then up.
and 7 units up. So this formula is going to give you your y coordinate. Y equals that. If you were going to solve for x, then you would need to set that equal to y and plug in and solve for x. Make sense? Mean value theorem. Okay? Good. So we just solved for x. X was the square root of 7, 2.65-ish. Confusing? A little bit confusing. Okay? That was example 8, and that's all we have. I don't know where we at. 168. Yeah. If you want to. 1, 6, 8, 14, 16, 20, 31, just A, and 45. There you go.
Can I go see if I have
Okay.
my